the session time is now changing. It's on the board. It's still going to be in the same room, TLC group 50. But now my Wednesday session is going to be from 5:30 to 6:20 for the rest of the semester. Also, this week I'm not going to be having my Thursday session, so I'm not sure, so I'll be there. But yeah, Wednesdays, 10 p.m. Thank you guys.
Okay, any questions about the SI pass? Everything's good? Okay. So today we're going to talk about chemical reactions. And in order to be able to solve the questions in this chapter and next chapter, you should know the materials that we talked about before, about mole, chemical formula, how to solve those problems. If you don't know how to solve these problems, automatically you cannot solve problems in this chapter and next chapter regarding chemical reactions. So if you have any difficulty with those, I encourage you to go to the SI pass, tutoring, or come to myself and we talk about those, okay? But if you learn the materials that we talked about in the previous chapters, these chapters will be super easy because previously we had like a chemical formula and I was telling you in 1 mole of carbon dioxide how many moles of oxygen we had. So can anyone tell me what is the answer? Exactly, 2, right? So in 1 mole of carbon monoxide, you're talking, in 1 mole of carbon monoxide, how many moles of oxygen do you have?
1.
Exactly. So we just look at the chemical formula and then have the relation between the moles. And when I talk this session, when I go through the lecture, you see that we have really similar concept with chemical reactions. But before we solve problems about reactions, we should first know what is a chemical reaction. And we briefly talked about this in our previous chapters. Can anyone tell me what is a chemical reaction? We refer to those as chemical change in chapter 3. Yes?
It's a change that changes the chemical composition of whatever you're working with.
Exactly. So, as your friend said, we talked about chemical changes and we said in chemical change, the composition of the compound changes. And in general, in chemical reaction, and I forgot to change this, I changed everything, but this one is the chemical reaction. So I forgot to change this one. So chapter 7 is chemical reaction. Chemical reaction is this chapter at the beginning, rather your book has an example of volcano eruption that you had like in your elementary school. Did you guys did this experiment when you were younger? So we have vinegar and baking soda, and if we mix them together, you see I had like a video feature when I upload this PowerPoint slide on Canvas. You can play this video, but in the PDF format it doesn't show, and here is also the YouTube link. Before we start, since I knew that is going to happen, I took screenshots of the YouTube video to be faster with the lecture. So you have soda and vinegar. When and soda is basically, it has bicarbonate in it, and we talked about polyatomic ions, right? So if I give you the table of polyatomic ions, you should be able to identify bicarbonate. And vinegar, is acidic, that we're going to talk about that, in this lecture too. So when you mix those together, let me go, there, add vinegar to baking soda, and then in this video, the guy put also ink or dye to the solution, so you see the change better, right? So it's kind of like when it's pink, it's like easier to see. So you see that gas is being released. It's kind of like eruption, right? And that is because carbon dioxide is released. And that is one example of chemical reaction, and we're going to study this reaction in detail. And I'm going to ask you in exam what type of reaction is that. And at the end of this lecture, you will be able to answer this question. And also in the attendance today, I included questions from the lecture that I'm teaching today. And in order for you to get the attendance, you should at least answer one of the 3 questions right. So I encourage you to pay attention. And if you pay attention, the questions are super easy. So I tell you these are types of chemical reactions, and then I ask you, name 3 types of chemical reactions. So as long as you pay attention, this is really, really easy. But I do that just to have you guys' attention and make sure you're learning. Because as I mentioned, if you don't pay attention in the class, don't study, you're not going to do well in your next exam and final exam. Okay, any questions so far? So is it clear that what is a chemical reaction? Can anyone else tell me what is a chemical reaction? Anyone?
Transformation of one or more substances into different substances.
Exactly. Okay. Here, transformation of one or more substances to new substances. When you burn oil or gas, right, or methane in the oven, or like the heat that you use in your house, if it's like burning of the gas, that gas reacts with oxygen and produces carbon dioxide and water. In general, that is a chemical reaction because you have 2 or more substances, or one or more substances, they react with each other and they generate, 1 or more substances. And you can have one reactant that produces, 2 or more reactants, or you can have, and we talk about, what is reactants and what are products and all that. But from now on, I expect you all to know that what is a chemical reaction. So can you tell me what is a chemical reaction?
Chemical reaction is the change of the chemical composition between 2 elements.
So the change of chemical composition between 2 elements?
Possibly.
Possibly, right? So we
Like
can,
in the lab yesterday, we had adding, like, say we had H2O and calcium tines, I think is what they were called. And so when we added the 2, there was a chemical reaction between the 2 that caused like bubbling and fizzing.
But those 2 things that you put together to react, are those elements or compounds? Is water element or compound?
Water is a compound.
Exactly. You can have, so the example that your friend gave is, 2 compounds. But you can also, as she mentioned, you can have like an element that reacts with another element or compound. That's why the general definition of chemical reaction is transformation of 1 or more substances into different substances. Okay, and substance, as we talked about, can be element, can be molecule, can be ionic compound, molecular compound, all different things, okay? So this is the definition. And as you see here, one example of chemical reaction would be combustion reactions, right? In general, burning of oil or gas in your car, if your car uses gasoline. So those are types of chemical reactions because the gas in the car is being burned and it produces carbon dioxide, right? Is that clear? Any questions? And just feel free to interrupt me anytime if you have any questions. So now you may wonder, how would I know if we have a chemical reaction? So some reactions actually show some evidence. So we have several reactions that occur that we don't see any change, kind of like some biological reactions that occur in our body, right? You don't exactly see what is happening, but they are happening. Or there are like some reactions that they occur, but they don't give us any signs, right? But there are several reactions that when they occur, we see a change. For instance, if I burn this table, you see, you know, right? First of all, you see a flame, you can see color change, right? Or more evidently, you can feel the heat and see light, right? So that tells you we have a chemical reaction. So some evidences of chemical reactions are, one is color change, right? So if you have like a plastic spoon and then you microwave it, like over the course of time, or like by using certain stuff, kind of like that, as this spoon shows here, right? You see color change. So why that happens? Because we have a chemical change, chemical reaction, right? So that can be an evidence of a chemical reaction. The other one can be solid formation, right? That if you mix two solutions with each other, you see some precipitates or solid being formed. And we're going to study all these reactions in much more detail. Or gas formation, like the volcano eruption, right? Baking soda and vinegar that we just explained. If you see bubbles or gas. And this one can be tricky because we also have physical changes that they produce vapor, right? For instance, if water, you boil water, you see also vapors, but that is a physical change, right? So make sure to know the difference. So if you see gas, it's not necessarily a chemical reaction. It can be a physical change. Does that make sense? Yes.
How would you identify that difference? Like, is there a simple way to like know the difference between whether that gas formation is physical or chemical?
Great question. So for your exam, I'm going to tell you which, is the following statement true or false. So I specify that. But it depends on the substances that react with each other that I tell you in the next slides that we call them reactants. It depends on your reactants as well. So if you only have water and then you see bubbles, there is nothing else present, you know that should be evaporation, that is a physical change. But if you have like two solutions that they involve, two ionic solutions, for instance, and then you add them together, you know that the bubbles that you see is because of a chemical reaction. So it depends on what you have, in your reaction vessel or in your kettle, if you're like boiling water, it depends on what you have. Without knowing them, if I just see some bubbles, some chemicals, they smell a certain way. So, you can identify them, but several of them, they're like odorless. Great question. Any other questions? Okay. Color change, solid formation, gas formation, any of these three. So that should be fairly straightforward. And I asked you in the exam too that which of the following is not an evidence of chemical reaction, or which one it is, or is the following statement true or false? When water boils, we see vapor, so we have gas formation. As a result, this is a chemical reaction, true or false? False, right? Because when water boils, it's a physical change. Any question? And some other, things that can tell us we have a chemical reaction is emission of light, right? And emission or absorption of heat. So here, we have emission. You see that you're seeing, heat, right? Or you can feel heat. In this picture we can just see it, but if there was a, stove here, we could also, feel the heat. And also heat absorption. That, here I also included the description that if you have the chemical cold pack, as soon as you separate these two parts that are separated by this barrier, as long as you break the barrier, you feel cold. If you put that in your hand, for instance, right? So that is because of the reaction that is occurring. It absorbs heat, so you feel cold. Does that make sense? So as I mentioned in the attendance, I told you what are some evidence of chemical reactions. Name 3 of them. As long as you say, for instance, heat emission, heat absorption, light emission, or questions so far? Are we good? Okay, now let me before have chemical equations in order to show our audience how the reaction actually occurs. So the definition of chemical equation is the following, the representation of chemical reactions. Or we can say we represent chemical reactions with chemical equations. Okay, and unlike equations that we write in algebra, that is kind of like, I don't know, a plus b equals c, this, that we put equal sign. For chemical equation, we put arrows. Okay, like this one here. And the substances that react with each other and produce, products, we call them reactants. So basically, it's the substances on the left side of the equation, these are reactants. And if you remember the definition of chemical reactions, we said one or more substances react with each other and create one or more substances, right? So those substances that react with each other, we call reactants, okay? And the substances that are generated from reactants, we call those products, as is written here too. And instead of equal sign, right, we use an arrow. Because we want to show that these substances react with each other, they produce. The arrow conveys our purpose better. Any questions so far? We're good? Okay. Now, and then the substances on the right side are products. So I'm going to tell you, ask you, which ones are products on right or left, which ones are reactants, okay? And also, it is useful for us to know what is the state of reactants and products. Are they solid? Are they liquid? Are they gas? So for that matter, in parentheses in front of the substance, we write the state of the specific substance that we have. And we do that for all of the reactants and products. Any questions? Going to this lecture, if I tell you I have water, right? So we learned in the previous chapter that it's an efficient way, to see what water is composed of, right? So if I tell you water and I ask you, what are water's constituents? What do you say? Hydrogen and oxygen, right? And then if I tell you how many oxygen atoms and how many hydrogen atoms do I have in one molecule of water? What do you say? Exactly. So what we do is that in order to convey this information to our audience, we write chemical formula, right? Now we have similar thing with chemical reactions. So if I tell you methane in the stove reacts with oxygen and it produces, carbon dioxide, right, and water. And if I tell you, or if I in general ask you what is the reaction of combustion, right? What are combustion reactions? So we should have an efficient way, like chemical formulas, to also demonstrate chemical reactions, right? And give information to our audience at how those reactions occur. That's why we... Okay. So the states that we can have for reactants and products are the following, and I just included this picture, this table from your book. So if we have gas, we write G. So this is like the first letter of gas, right? G. So liquid, you write L, the first letter of liquid. And then if you have solid, you write S. And then if you have a solid that is dissolved in water, we write aqueous. So aqueous is basically water solution, okay? And we write that by AQ. So if you have aqueous, you write AQ, and indicates a substance, the substance is dissolved in water, okay? And we call the resulting, mixture, we call that a solution, okay? Can anyone tell me this solution, would it be homogeneous or heterogeneous mixture? Homogeneous, right? Because when you dissolve, for instance, salt in water, right? If it dissolves, you cannot distinguish between water and salt, right? And then the composition of salt in water is the same throughout. And if it doesn't dissolve, if you can see, the substance that you're mixing, if it doesn't dissolve, you have a heterogeneous mixture, it won't be solution anymore. Does that make sense? Any questions? Okay, so you should know these abbreviations, and it's just like the first letter or the first two letters. So it shouldn't be much difficult to remember. Just aqueous, remember, is your substance is dissolved in water, okay? Now, we want to write chemical reactions. We want to learn how to write a chemical reaction. If I tell you methane, reacts with oxygen and produces carbon dioxide and water. Okay. So methane, I give you the formula, so you don't have to worry about it. It would be CH4. Okay. But for oxygen, you should know that when I just say oxygen, oxygen exists as diatomic molecule, right? So you should be able to identify that. And also carbon dioxide, you should be able to write the formula for carbon dioxide. And water, I guess water, you know that is H2O, right? But anything else that we didn't learn in this class, how to write their formulas or write their names, I'm going to give you those. Okay, so you don't have to worry about that. But anything else, molecular compounds, ionic compounds, you should be able to write. And also acids, I'm going to teach in the next class or so to how to write them. So you should be able to write those. So that's why if you didn't learn chapter 5 and 6, basically you cannot write reactions because you cannot write the molecules or ionic compounds. Does that make sense? Okay, so for methane, as I said, I give you methane that is CH4, and then it says reacts with oxygen. It means that these are your reactants because these substances are reacting with each other, and they produce carbon dioxide and water. So this is the first step for you to be able to identify what is or what are your reactants, what is or what are your products. And for the state of this, for oxygen, you should be able to identify, let me write these a little bit space. If I write CH4 plus O2, so in this case, for instance, for oxygen, you should be able to identify that it is a gas, but for the rest, I will give you the states, right? And the ones, as I lecture, the ones that I expect you to know, I tell you to remember, but the ones that you cannot easily guess or we didn't learn specifically, I'm going to give you the states, so you don't have to worry about that. Produces carbon dioxide, which is gas, plus H2O, that is gas. Okay. So one thing that we studied before in chapter 3, it was law of conservation of mass. Can anyone tell me what that law said?
Mass
Yes?
is
Exactly, mass is not generated, doesn't generate and doesn't destroy, right? So if we have like a reaction, if we were burning carbon dioxide, we're burning methane here, right? And we call these types of reactions combustion reactions that we're going to talk about. But in general, if CH4 reacts with oxygen, right, you have which elements here? Carbon, what else? Hydrogen, right? And what element oxygen molecule has? Oxygen atoms, right? So in general, you have three elements total on the left of the reaction, okay? So can anyone tell me what elements I have here? So what elements carbon dioxide has? Carbon, what else? Oxygen. What about water? What elements it has? Hydrogen and oxygen again, right? So, do you see any element, in your products that you didn't have in real reactants? Do you? No, you have the same elements. So when you write chemical reactions, you should have the same elements on both sides. This is one thing that you should remember. Okay, and it helps you to write reactions. As we're going through the lecture, you should write different types of reactions, and this helps you to write those types of reactions. Okay, so, and then here your book also demonstrates that here, not only we should have, the same elements on both sides, we should have the same number of elements. So here we have 2 oxygen atoms on left, right? How many in total oxygen atoms you have on right? 3, right? So if you write the equation as it is, the law of conservation of mass is not preserved, because law of conservation of mass told us matter is not created nor destroyed, right? So the same, whatever number of atoms you have on the left, you should have the same number of atoms on the right. Okay, so let's talk about this more. So here, for CH4, tell me what elements I have. Carbon, hydrogen, right? So how many carbon do I have here? 1. How many hydrogens? Exactly. So this is for CH4. I write with another color. For oxygen, how many oxygen atoms I have? 2, right? And then I write with brown here. For carbon dioxide, what elements I have? Carbon, oxygen, right? How many carbon atoms I have? How many oxygen atoms? And finally, for water, which elements I have? How many hydrogens? How many oxygens? 1. So in general, in total, let me choose indigo. Okay, here, for carbon, hydrogen, oxygen. In total, how many carbons I have? How many hydrogens? How many oxygens? If I do for the products, for carbon, hydrogen, and oxygen, how many carbons I have? How many hydrogens? How many oxygens? In general. So you have 2 here, you have 1 here, right? So how many it would be? 3, right? Are you following what I'm doing? I'm just like counting the number of atoms in each molecule and then add them together to have like the total number of atoms, each specific atom for reactants and products. So this reaction, we say it's not balanced. It means the number of elements, the number of atoms on both sides of the equation doesn't match. So whatever number of carbons you have on the left, you should have the same number on the right. So what we do, if I just write CH4 plus, and I write the state 2 so I don't confuse you, plus O2 gas, and then CO2, it produces CO2 gas plus H2O gas. And I tell you, balance the following reaction. It means the number of atoms on left side for a specific element should equal the number of atoms of that specific element on the right. So what you do is that this is the rule, and as long as you know this, you can answer questions that I asked you in the exam. The element that is by itself, you balance it at last. Okay? Because, when I was learning these things, we would try to solve the equations by ourselves, and they would give us headaches, and then, it takes a while for us to learn ourselves that, okay, if we have like element by itself, I should balance it at last, right? But now, I just kind of guide you and then give you the answer from the beginning, but you're welcome to try balance it some other way and then see the difficulties. Because if you start, with oxygen, right? If I just want to have like the same number of oxygens on the right side, I put like a coefficient here, half, and then number of carbon atoms now don't match, and I put a coefficient here, and now number of hydrogen atoms don't match, So it would be much more difficult or sometimes impossible to balance it. But the bottom line, the procedure is that the element that exists by itself, whether it's like oxygen atom or like O2 or like magnesium ion or something, element by itself that is not bonded to another element, you do that last. Any questions? So now let's start with carbon. So what we do, we count the number of carbon atoms on left, and you're welcome to just write it as I did before, okay? But to save time, I just ask you and then write the answer. So how many do I have on left in total? 1. How many do I have on right side in total? 1. So this carbon element is already balanced. We have the same number of carbon atoms on left and right. Okay, I told you hold on to oxygen to take care of it the last. Okay, now let's go to hydrogen. How many hydrogens I have on left side? How many do I have here? So in order to balance a chemical equation, we put coefficients here. Okay, so what coefficients? So I have like H2O here, and it has a coefficient, right? What coefficient should I put here in order to have 4 hydrogen atoms? I already have 2. 2, right? If you put 2 here, what we do, we multiply the coefficient with number of atoms. So 2 multiplied by 2 equals 4. And this is really important that you put coefficient. You won't change the subscript here. And can anyone tell me why? Why didn't I just write H4O?
There wouldn't be water.
What's that?
So it wouldn't be water.
Exactly. So H4O, we learned that it's not water. We said that, law of constant composition. Remember that when we have water, we always have 2 hydrogen atoms for 1 oxygen atom. So that's why we cannot change the subscript. We put coefficients to show that we have 2 water molecules. Any questions? So now we took care of hydrogen. Now that we're all set, we go to oxygen and count the number of oxygen atoms here, and then change this coefficient accordingly. And that's why we put that last, because whatever we got, we could just get, put the coefficient for oxygen. And when I solve it, you know what I mean. So what is total number of oxygen atoms in these products that we see here? Exactly, you have, this coefficient when we don't write anything is 1. Remember, some students think that is 0. If it's 0, it means that it doesn't exist, okay? So 1 multiplied by 2, right, plus here this number is 1, right? 2 multiplied by 1 equals 4. So now, what coefficient should I put here for oxygen in order to have 4 of that? 2, right? And this is how you balance a chemical equation. And here is the basically whatever I wrote, it's just like nicer version, I guess. And you should know the numbers of each type of atom on both sides of the equation are equal. And that means the equation is balanced. And I asked you in an exam, by balancing a chemical equation, what law is preserved? Law of conservation of energy, law of constant composition, law of conservation of mass. Which one?
Conservation of mass.
Exactly, right? Any questions? And when you talk in the class, not only you distract me, but also you distract your friends too. I have students that they come to my office hours and they tell me they cannot concentrate because people in front of them are just talking. So if you, even if you don't care about your self-learning, and even if you know the materials, please, think of your classmates. Maybe they want to listen, okay? And bottom line, I want all of you to succeed. I try my best. And you see, I schedule like Zoom meetings with you, even like during the weekends, after hours, respond to your emails fairly quickly. I think, I do my best. And then anytime students ask me questions, sometimes I just like record videos for them. I just like do my best for all of you to succeed. But, I kind of like expect the same respect from you, so. Anyway, so now we want to talk about different types of reactions. And this topic was giving students a hard time last semester. And I have like pictures here and like, have the text in the slides too. So it won't be any confusion. So one type of reaction specifically is precipitation reactions. And we talked about that briefly in the first slides that I showed you about like evidence of a chemical reaction. And can anyone tell me based on the name, and you have the answer here too, just feel free to read it, comprehend it, and then answer the question. So what would be a precipitation reaction? What do you think it is? Anyone? Yes?
Like a solid in a liquid or solid forming?
Exactly. So you have two aqueous solutions, because most of the reactions that we're encountering, at least in this context, they occur in a liquid phase, okay? So you have, or like aqueous phase, sorry. So you have like aqueous solutions, so you dissolve one salt in water, as a result you have an aqueous solution. You dissolve another salt in water, and then you get another solution. And then when you mix them together, you see a solid being formed. And you have a table in your book, solubility table, and tells you which salts, if you have aqueous solutions of those and we mix them together, they precipitate. Basically, they form a solid, and we call the solid that is being formed precipitate. That's why we call these types of reactions precipitation reactions, okay? And I'm going to give you that table as well, and we're going to go through more examples in the next class. We cannot go solve questions in the last class. But we're going to also, have like more examples in the next session. But for now, just know the definition and know what it means. So, for instance, as I said, aqueous solutions, most of the time, at least in the context of the course that we're studying, there is an ionic compound that is dissolved in water. That would be, aqueous solutions that we're dealing with in precipitation reactions. We mix them with a solid, kind of like this reaction here. And then in this case, the precipitate has which is PbI2. Can anyone tell me the name of this compound? Yes?
Is it lead to iodine?
Exactly, lead to iodide. And first of all, what type of compound it is? Is it molecular or ionic? Ionic, yes, thank you. When you don't, say anything at some point, I'm like, shoot, they don't know this? I mean, if you don't know, come talk to me. So, in your exam, I may just tell you that write the reaction of lead to, write the reaction of lead to nitrate with potassium iodide. So if you don't know how to write them, you cannot answer the question. That's why I'm emphasizing to studying the previous chapters. And you have your SI Pass leaders. They hold several sessions for you. So you can just learn the things that you didn't learn quickly. Anyway, so we have a cation plus anion, or in general, metal plus non-metal. Most of the time, except NH4 plus, which is an cation and forms ionic compounds. The rest would be metal, non-metal. Okay, so this, this precipitate has a yellow color. So, you can see precipitate and also you see color change. That's why you have a chemical reaction. So this is one type of reactions, precipitation reactions, okay? The other type is acid-base reactions. So acid-base reactions are reactions that you mix an acid with a base and you see water as your product. And most of the time you see also a salt, which is an ionic compound. So you may ask me, what is an acid? We didn't talk about that. Or what is a base? So that's why I have, this part of your book, just copy and paste it from your book. And as I said in the first slide, anything that I don't cite, I just got from your textbook. So acids, they have hydrogen in their structure. And bases have OH in their structures. And here is just kind of like more explanation, and I asked you to read that. I'm going to ask you true or false, which of the following statement is correct, is not correct, all sorts of questions. So know that acids, they have sour taste, they have the ability to dissolve metals, they have tendency to form hydrogen ions, basically H plus, in solution. And hydrogen ions, we also call them protons. But you don't have to worry about that. Just remember H plus ions. And a base is composed, base is a compound characterized by this bitter taste, right? And it has like a slippery feel, and it has a tendency to produce OH minus ions. And can anyone tell me off the top of your head what is OH minus name? Is a polyatomic ion. Hydroxide, right? And you have some examples of acids and bases. I'm going to use the same color that I used for acids. So lemons, limes, vinegar, they have acids, and soap, coffee, milk of magnesia, they all have bases. Okay, in the this context that we're talking about, remember that acids have hydrogen in their structure, bases they have like OH. Okay? And we have like more broad definitions of acids and bases as well, but for the context of our course, this is what you see. If you see OH, that is a base. If you see hydrogen, that is an acid. And when you mix them together, based on what I just wrote here, what do you think will be produced? HOH. Can you put that together and then H2O, right? So it produces water. And most of the time, you also see salt. And in the next class, I'm going to talk in more detail about these guys, these types of reactions, and then giving you more examples. Another type of reactions are gas evolution reactions. Can you guess what is the definition? Yes?
A reaction that occurs in solution and forms a gas as one of the products.
Exactly. Can anyone give me an example? Just the volcano eruption example that I just gave at the beginning of the class, right? You have like baking soda, you mix it with vinegar, and then you see carbon dioxide being generated, right? So a reaction that occurs in solution and forms a gas as one of the products. So that would be gas evolution reaction. So this is the same reaction that I showed you at the beginning of the class, and as you see, since they didn't use a color, you still can see bubbles, you get the idea, but I guess if you put an ink, it shows it better that you have like gas evolution reaction, but this is basically the same reaction. The other type of reactions are oxidation reduction reactions. And one example would be, rusting of iron, right? So you see the color change, and also instead of iron, you'll see iron oxide, because iron reacts with oxygen in air, and then it becomes oxidized, right? And in general, the definition is the following. Oxidation reduction reactions, they are reactions that, in which electrons are being transferred, right? You have one compound with the other, and one compound loses electrons, or specific elements of that compound loses electrons, the other one gains it. And that is basically the definition of oxidation reduction reactions. And one type of oxidation reduction reactions, one type is combustion reactions. And the reason combustion reactions are also oxidation reduction reactions is that electrons are being transferred when methane, for instance, reacts with oxygen. They transfer electrons. And I always ask that in the exam, and I'm going to also ask it, is the following statement true or false? All combustion reactions are oxidation reduction reactions. True or false? True, right? Combustion reactions are subcategory of oxidation reduction reactions. And the general definition of combustion reactions is that you have a substance, it reacts with oxygen, and it produces oxygen containing a species. And also heat is being generated. So a reaction in which a substance reacts with oxygen, emitting heat, and forming one or more oxygen containing compounds. Okay? Any questions? And before I forget, you have your homework 10 due tonight. Question?
So, would your blood going from blue to red be an oxidation reaction?
What's that?
So like human blood, like when it's exposed to oxygen, its like color changes. Would that be an oxidation reaction? Or technically no, because like the substances within are like inactive.
So I think that would be oxidation reduction reaction, but I should, look through the reactants to make sure that, electrons are being transferred. So I think so, but I'm not 100% sure. But great question. Yeah, I'll look into it and let you know. So I zoom this a little. And if you have any difficulties with chapter 5 and 6, please reach out to me. You know, I schedule Zoom meetings with you, in-person meetings. You know, as long as you want to do well in this course, I make sure that happens. So.